We have no music because it's Josh's fault because
It
he's
is.
on vacation, which you can see because you can see that he's in a hotel room. And our guest today.
Although I'm taking that painting with me.
I was expecting some kind of response there, some sort of witty response.
This is vacation brain, so we'll see how this episode goes.
Joining us today are our special guests, Andrew and Nerman. Would you like to introduce yourselves?
I'm not
Sure,
Norman.
I guess I can start. So I'm not Andrew.
And let me complete that. Just for go on, Norman.
I guess we both run the Scala Puzzlers website. We kind of collect them and publish them. We also wrote the Scala Puzzlers book, and I think that pretty much sums it up.
Great. So that doesn't mean that I don't have to say anything anymore because Norman has said it all. But that is totally correct. The one thing I should add is that actually you as in the Scala community, really own and run the website. We're just like the curators and maintainers. So it's not just us spending our time finding these puzzlers. It's up to you. But we'll get back to that maybe a little bit later.
Nice. And you guys have been involved in Scala for a long time, right? Norman, didn't you? I don't know if you still do, but you ran the Boston group for a while, or helped out.
Yes, that is correct. So together with a couple of other folks, I started the Boston Scala user group in 2009, I believe. Yeah, and have been running it since for the last couple of years, actually, together with Seth Tishu.
Wait, who's that guy?
Just some Johnny-come-lately who was, brought in when the OG founders disappeared.
Oh, I see. So, I thought your name was not Josh Surratt. Oh, yeah. So you guys have been around for a while in the Scala community. What led you to want to make the Puzzlers to begin with?
Not Andrew. Would you like to go first?
Sure. Yeah. So essentially, what attracted me or made me think about doing it is that I enjoyed Java Puzzlers a lot, which seems that it's not something unique, that a lot of people in the Java community enjoyed as well. And I thought that the book was pretty great and all that, but Java Puzzlers are kind of not publicly available, if you will. So around the same time, I also started noticing on the mailing list, on Stack Overflow, people running into these kind of interesting code snippets, wondering, why is this producing certain output and all that. And I thought, a similar effort can be done in the. At that time, I actually was not aware. I think even before that, Andrew posted a question on the Scala mailing list about what do other folks think about launching, some version of Scala. I guess I kind of missed that post, but in thinking kind of that way, I basically, the first thing that comes to your mind is, I should probably get some domain, and scalapuzzlers.com was already taken, but I kind of liked it a lot, so I thought, let's see, maybe I can acquire it. And, I did a little bit of research, and I, Andrew's name, and I realized it wasn't only Scala Puzzlers, there was a whole bunch of other Scala domains available. So I realized, well, in this case, I'm going to be dealing with a domain dealer. That was kind of my assumption. And I reached out to Andrew and said, okay, how much would Scala Puzzlers, .com cost? And Andrew asked, why are you interested? Me totally kind of, unaware that Andrew is a Scala enthusiast as well. And, I guess it started from there, and the rest is kind of history, if you will.
So it all started with the Google stuff.
Andrew does look like a domain dealer. I mean, you have to say, right?
Well, come on. All domain dealers look like this. So a lesson for everybody out there. This is the reason why you need to have like domain privacy things on your whois, because otherwise you get people like Norman finding you and emailing you. So the story, I mean, the backstory here, I think, just in terms of my my motivation. It's very similar to what Norman said, like as a sort of Java refugee. One of the things that always appealed to me about like languages and programming in general is that part of it, I like to scratch that particular problem-solving itch. It's just not very fun to scratch that problem-solving itch when your production server's on fire and oh my God, Java lang string not equals Java lang string, and we've all been there. That's not a fun time to try to understand how you don't quite understand the language the way you think you do. So what I really liked about the Java puzzles was it sort of, you can go and you can sit on the can or whatever, sit in with your morning coffee trying to wake up and try to challenge yourself a little bit, learning without the stress. And as Norman said, the Java puzzles are a good inspiration, but they were indeed a well-organized, written, carefully curated book. And I thought back in the day, that's so like 1990s, we tried to do things on a more community-based basis. So the Scala Puzzlers became a website precisely because the idea was that we shouldn't have a couple of ivory tower people going and like selecting these, but like museum curators, but people should be able to contribute them. And I think we might get into this in a little later in the discussion. It's not just a sort of curiosity thing. Oh, look, they found a weird expression that does strange things. It's really a learning tool. And I think that for me was I learned a lot through the language.
So, what other domain names are you squatting on that we can expect books from in the future?
Don't ask, actually. There's way too many, but I'm not going to go and advertise them. I think one of the ones that I thought might be fun with dear old Bruce was the Scala side, which never became a book. Ironically enough, I also own programminginscala.com, which, of course, redirects to the Artemis site because clearly I would not abuse my editor by pointing it somewhere else. But yeah, let's. There's one domain that I'm particularly proud of that we may get onto later, but we'll talk about that when we get there.
Okay. Okay. All right. So if I need a Scala domain, just don't even go to GoDaddy. Just go straight.
Come on, bring it on, bring it on.
All right. All right.
So who is your editor? Who took this project on?
Well, I'm not sure whether we could say he took the project on rather than we foisted it onto him. But it was the book was edited by Bill Venners with Jessica Kerr's very able help. And yeah, again, to me that was one of the best experiences. Somebody who has even more Scala experience than a lot of the people on this in this particular Scalawags episode, which is quite remarkable. For someone like that, someone like Bill to turn around and say, I learned things about Scala that I wasn't aware of before, through the process of going through some of these examples, it proves to me that there is definitely something even the most experienced Scala programmer can maybe learn. And that was a great, very fulfilling thing to hear.
So were you worried at all that this would add to the Scala is complex debate?
Not Andrew. What do you think?
So I think that's a fair question, and you can kind of try to put it that way. And I actually noticed on Twitter, some comments, when people come across the website or they, see the book saying, well, this is just another proof that, Scala is so complex. But I think, everything you kind of, you think of it, if you just superficially approach it, you might kind of come to a wrong conclusion, right? So I actually, to be honest, myself, I thought very hard in the beginning, against writing the book. Andrew can kind of, confirm that, because I thought, well, everything is available on the website. What's the point of writing it? And I knew, or kind of assuming that it would be a huge effort. I didn't want to write a book just for the sake of writing it. But then, then I realized not only that, we can see a lot more in the book that actually is, explained on the website. We can go a lot deeper, but I also realized that the book itself can be, can be another way, or let's say a more fun way to learn about Scala through these examples. And it wouldn't be a book that, you necessarily read from cover to cover, but you kind of, read a little bit, maybe a puzzler or two, and just kind of put it off and then pick it up again. So seeing it that way, and once you start reading, you basically, I hope that the readers would kind of come to the conclusion that the goal of the book is really to deepen your knowledge about the Scala and kind of provide, a more fun way to learn about it, rather than kind of expose the complexities and so on. Although we do have to admit there's some there's some puzzlers which in the book or on the website which are kind of like really weird or I wouldn't say like really bad, but I think those are the ones that EPFL and TypeSafe kind of decided that they would be removed in the future versions. So, but those are, I would say, those are kind of minorities. So, so I guess that was my opinion, or the long answer to say kind of no. But I would be interested in not Nerman's point of view.
Well, I mean, there's a couple of elements to this. First of all, like the truth is out there. We didn't invent these puzzlers. These are all things that are already on Stack Overflow or Scala Lang or whatever. So you will find them. And I think, as Nerman says, if anything, having them cataloged in this way provides like a target list of maybe your 50 most wanted. And as we know, TypeSafe has picked up this particular mantle and has decided to shoot some of them down, which I am very grateful for, because I think that's the best thing we can do. I think going beyond that, I mean, our puzzle, why? It's also a little bit like, do we want to pretend that Scala doesn't have of the potential complexity? I was at a meetup yesterday where, actually, ironically enough, somebody recommended the book. Didn't know I was there. It's kind of very nice because I was late. But no, they were talking about, the most important thing about Scala is knowing which bits to touch and which bits not to touch. And people have done that in many different ways, whether it's through style guides or other kind of documents. And to me, Puzzlers is just maybe a slightly more fun way of doing that. So I think the more fundamental question is, which parts of Scala are puzzling without added value? And I personally, I believe, having worked with many different languages, I mean, hey, let's talk about it. Like, if puzzlement were a criteria not to use a language, nobody would ever use JavaScript, right? There are some, I think any Turing-complete language will have some element of puzzlement, because puzzlement is not just about things in the language itself, it's also about the expectation of the programmers who are writing code. And sometimes that expectation is just flawed. We humans, oh, I am breaking up so much, I hear. Thanks, Nerman. Let me see whether I can go fix it in a second.
Yeah, Andrew, I can hear you fine. Nerman, I think the problem might be actually with your connection.
We've located the problem on Nerman's end. So let me then continue. I think. So what I was trying to say is that part of puzzlement is also about what we as developers think the code should do. That's not the code's fault. That's really to some extent the fault that our expectations don't match exactly the way languages work. But certainly, it's legitimate to say, I think, that Scala has some elements where it's behaving weirdly that they don't deliver additional value, right? And I think part of seeing Scala evolve over time is trying to understand where some of the puzzling behavior is intrinsic, if you like. It's a trade-off between delivering power and resulting in some weird effects as a result, versus where it's more accidental. Choices that we would rather have back, things that didn't turn out like they worked the way we wanted them to do. And there, yeah, hopefully, future versions of Scala or Dotty, which will solve all the problems, Silver Bullet Dotty, will get rid of some of that stuff.
Silver Bullet Dotty, that's going to be the new tagline on the website. Silver Bullet Dotty. All things fixed. All problems solved. So actually, I was thinking, since I have 10 minutes, I'm kicked out of my hotel. Maybe we should look at one of these puzzlers to show people the experience of how awesome it is to look at corner cases in Scala.
All right, let's do that. Maybe let me pick one that's kind of nice, and I'll try and pick one that is actually not. I'm not going to do this one from the website because I'm going to pick one that is incredibly fresh, so new that it's not even out there yet. We're still debating it, and I'm going to pick one that is not. Actually, well, I would consider this to be an example of intrinsic puzzlement. In other words, this is not something that we would like to fix. This is just a fact of the way Scala allows things to work, and that'll give you a good idea of where. I don't think we can get rid of this. This is just a matter of understanding stuff. So for those of you who've been diligently following Scala Lang, the answer will be boring because it's pretty new on there. But here's your puzzler. So the code itself is this, right? We have two streams defined, and like streams are generally defined, they're defined in terms of themselves.
Hey, Andrew, if I can interrupt you for a sec. Yep. Does this puzzler have a number on the site?
No, it doesn't yet. It's brand new. If we want to do one on the site, let's pick a different one.
No, it's okay.
Yeah, we'll do the new one. We're gonna prove this one, and then
Let me make it a little bigger because I think the font size is not exactly huge. Pick a nice big font size. Right. Oh my God, that's way too big. But anyway, can you see it?
Yes.
Great. Okay, so we have two streams defined. The stream of natural numbers, starting with 1, and then taking the stream and adding 1. And then we have the stream of odd numbers, which are, they start with 1, and then they filter out all the numbers that are even. And what we do then is we try to print the first two odd numbers. So in the first case, we do so by taking the natural number stream, filtering it, and then printing the first two. And in the second case, we take the odd numbers and just take the first two of that. And so here, we'll make it a little bigger so you can see the candidates. So the 4 candidates are, oh, now I'm going to make it smaller again because you won't see them all. Maybe do it like this. So here are the 4 candidates, right? So the first one, it prints, oh my God, sorry, 1 3 1 3. The second one is it prints 1 2 1 3. The third candidate is the first statement prints 1 3 and the second throws a runtime exception. And the fourth one is the first one throws a runtime exception and the second one prints 1 3. So let me go back to the code to give you a chance to review that.
All I have to ask is, why are these not lazy vowels?
That's a very good question. Because they were not in the Stack Overflow answer originally. But the good thing is, since this isn't published yet, we can already fix that.
I think that might change your answer possibly too.
Would it? Well, we can check, right? We have a REPL. Well, I will certainly check afterwards. But in any case.
Yeah.
So I actually saw the thread about this. So, I'm not like a perfect experimental subject here, but yeah, certainly the fact that I would have expected something like this to be lazy val in order to work at all is the first thing that jumped out at me as well.
Yeah.
Well,
because you're instantiating the stream to 1 and then some sort of thunk, and the thunk is looking up nats, and nats.
Yeah, I was.
Is it defined at the point where you look it up? Is the question. I forget the actual signature of bang or pound.
Okay, so this is stream append, right?
Yeah, it's stream append, right? But I forget what the signature is. Does it take the second argument lazily or not?
So yeah. So sorry, I mean, there is no candidate that says neither will compile. Like they both compile. And so that's why I think making these lazy would not necessarily make a big difference, because all the lazy would do is to change the moment at which this expression is compiled.
Well, no, the lazy would change when you grab nats, because it is possible that you could grab nats when it's still null.
Okay, sorry, yeah, no, but to be clear, this is not like null or something like that. I can go so far as to say this is legit.
Okay. Am I allowed to look at Scala doc?
Yes, you are. Most definitely. You could even put it in a REPL. That might be more fun for people to actually see what really happens.
I will. Here's what I'll say. I have avoided stream since the early days of Scala. I do not use it.
Well,
see, I would actually characterize this as more of a logic puzzle than a Scala puzzle. Like, if I recall the thread correctly, it comes down more to just the logic of what's going on than to, like, Scala quirks.
Yes, you're absolutely right. I think this gets a little bit to the definition of what you think a puzzler is. So the reason this is a candidate puzzler, after all, we can still shoot it down. It's a logic puzzle. I chose one that isn't like Scala being really quirky, but I chose one where maybe the programmer's expectation of what would happen is violated. You see, I considered this as a candidate in the first place, is that all you're really doing is...
Oh, we lost you. Or I lost you.
Yeah, we lost Mount Norman. I don't think if it's really about the logic, I don't think that makes it a bad puzzler necessarily.
Yeah, so now that I know what the bang does, it doesn't appear to actually be lazy, though, because the right-hand side needs to be a string.
Wait. What are you talking about with the string?
Oh, the append thing. Sorry, the right hand side is a stream, right? So we have nats map underscore plus one. I'm trying to figure this out because I haven't looked at it or done it in the REPL.
Yeah, and I mean, if it helps, the stream append, the thing on the right hand side is definitely by name.
Is it by name? Because I was just looking at stream itself. This is one of those situations where the operators are inverted. So you would get nats equals nats map underscore plus one dot pound colon 1, right?
Oh, now you're having me. I sounded so sure, and now you're having me doubt myself.
Yeah, I think when this rewrites, it rewrites to the second expression dot operator first expression, right?
So let's go on.
Hey, I think well, you're back anyway.
I know. I was disappeared then. I was so into puzzle land that my internet connection was puzzled. But I hope I am back. So let's briefly go through this one, and then to give people a taste of one that's slightly more maybe Scala quirky. We can have a look at another one briefly without spending so much time on it. So what?
You're muted. And
we lost him.
All right. And he's back. Yeah.
And you're muted.
All right. Guys, we never have technical problems.
Never, ever. We're never ever having technical problems, but that's because we never have me on the call, right? So let's go. Let's go.
Just hold the book in front of the camera whenever we have.
Oh, I love that. I'm sorry, everyone. So let me find that wretched screen share button. Everything was so good, and suddenly Hangouts told me like your Hangout is dead. Like I was like, what did I do? That was a bit unfair. So I'm supposedly sharing my screen again. So let's briefly go through this one. The correct answer, in fact, is 3. So what happens in this case is the first one works just fine, and the second one actually ends up with a stack overflow, which is kind of interesting because as Seth said, it's a bit of a logic puzzle. The point is that the recursive definition, well, what this definition means is that if you want to take a second element from odds, you have to take the first element from this stream, which means you have to try to calculate the first element from this stream. So the first element from this stream, well, you start out with the first element of odds, you add 1 to it to give 2, and then you filter it, which means that you don't get anything, which means that in order to try to calculate the first element of this stream, you actually need the second element of odds. But the whole point is that the second element of odds is what you're precisely trying to calculate right now. So in order to calculate the second element, you need the second element, and you've set up an endless loop. So it keeps calling effectively odds.take until it blows up. Whereas in this case, nats, this will always work because you can always take the previous element of nats and add 1 to it. So down here, if you want to take 2 elements, you take the first element, which is 1, and that passes your filter, and then you print it, so you get 1. And then you try to take the next element, which is 2, which doesn't pass the filter, so you try again. You take the third element of nats, which is 3, which again gets through the filter, and then you're done. So I guess the lesson from that one is moving the filter expression around when you're using streams can have an interesting impact on whether the stream can actually compute itself or not.
Oh, right. So the whole expression for odds, the 1 pound bang bang odds map underscore plus 1, that should actually be in parentheses, and the filter should be after it, right? No, not that expression. Yeah, the first little bit. Yeah.
Yeah. That would probably change the precedence here. I haven't tried that particular variant, but I think that would make a difference. And this is, by the way, for those who don't know the site. Oh, well, it's not sharing because Hangouts has shared only something else. So let me just quickly show people the site. It's scalapuzzlers.com, unsurprisingly. Where is it? It's one of the 10 trillion windows I have open. Oh, it's the Hangouts window, but it's actually over here. So let's pick a slightly different one, maybe very briefly. let's pick this one. This is kind of it's not pure Scala in the sense that it's about futures and the libraries a little bit, but I think it's also a useful lesson.
So this is Puzzler 56, it appears?
This is Puzzler 56. What's the name? People out there, you can experience for real for yourself by going to the site. It's on in the left-hand side in the menu. It's called, what's it called? An exceptional future. So the idea is you have a future which blows up with an error, but you have a recover with clause that catches errors and says we're going to ignore errors because we don't care. And then you have an on-complete which says, okay, if the future was successful, we'll print yay and then the result. Whereas if the future was a failure, we'll print oops and then the exception message. And then you have the 4 options.
We're all just staring at this.
Yeah, I know. This is it. For if you're doing audio, if you're listening without video, this is not going to be that much fun. Maybe we'll make it quick. Go on, Seth or Josh or not Andrew. Make your guess.
Well, I'm trying to remember. Error is Scala.error?
No, it's actually Java lang error, I think.
And what does that extend?
Ooh, let's have a look.
It extends throwable, but not exception. Right?
Exactly.
Yeah. What I'm trying to remember is if that I think that does not get caught by non-fatal error.
A non-fatal exception, you mean?
Yeah, I don't know if it's I think because error is so low in the hierarchy, it might actually be a non-fatal, or it might be a fatal exception as opposed to non-fatal.
So you think it might blow up actually?
Yeah, but the problem is if it does blow up, it doesn't blow up on your thread.
So let's for the poor souls listening on audio and boring themselves to death, let's quickly have a look at the answer. So the answer is actually boxed error, which is kind of interesting because basically somewhere in the future documentation it states, if you've read it, which everybody has no doubt, it states that any error that is thrown within a thread's execution or future's execution is turned into a boxed exception, an execution exception, I think. So you can't actually catch an error in this way. Nothing will happen. So the thing is a failure, so it doesn't blow up on your thread, as you said, Josh. But if you were to catch an exception here, it would work. So the notion is, if you want to catch errors in your threads, you have to actually recover with execution exception, which is an exception rather than an error.
Right, because they're different parts of the hierarchy. Yeah.
Exactly.
Okay, so I was on the right track, and I knew it was related to all that crap. But yeah, for those of you who don't know, knowing when to allow an exception to bubble up is actually a really hard problem, because there are times where you want the futures to actually throw the exception as opposed to catch it legitimately. These are things basically like if you hit an out-of-memory exception, there's almost nothing, like the act of trying to recover might lead to another out-of-memory exception, right? So those are really, really hard things to handle, and there's a whole list of things in the documentation of what to do when you encounter errors, because errors are different than exceptions, like out-of-memory error, stack overflow error, or I guess it is a stack overflow exception, but anyway, and those you can sometimes recover from, but the point is there are errors, and they are different than exceptions, and things can leak out of a future and never get caught.
So yeah, indeed, and for anybody who's interested in the details, there's a long and interesting discussion thread in various issues about which specific errors should be part of what Josh was referring to, called non-fatal errors. So Scala makes an opinionated decision about which errors are really lethal and which errors are recoverable, and that decision has been changed in the past, and I think it is indeed. Yeah, it's a class called, what is it, non-fatal?
It's called non-fatal. Yeah.
Yeah.
I think it's just called non-fatal.
Yeah, I mean, there's a very similar distinction in Java. Java doesn't have this non-fatal trait, but I wonder how many Java programmers understand all of the differences between how error is handled versus how exception is handled versus how runtime exception is handled. and of course some of that comes through to Scala and some doesn't, because we discard this concept of checked exception, but then we add this other concept of non-fatal.
Yeah, there's actually some really fun exceptions that I've had to catch and deal with. My favorite is actually the JVM linking errors that get thrown. So no such method error. Not no such method exception. No such method exception is a great one. That comes from the reflection library when you try to reflectively call something. No such method error is an error which happens if you are using a newer jar that has an interface with a method. Everything in your program will be fine until you try to call the method and the person who implemented it didn't implement the method from the interface or from the trait. Then it explodes with no such method error. But you can actually remain binary compatible by catching these things and then providing a default implementation for people. It's a pretty fun trick that we use in SPT, and it is something you can recover from, but it's also like really diving down in the dirt of the JVM. Generally, errors are things that are meant to be relatively fatal, but a lot of them can be recovered from. So.
Yeah. Java exception handling is usually just try, catch, exception E, throw new runtime exception E. Wasn't that the standard pattern?
Yeah. I think we've all written that.
Yeah, I know.
Yeah.
So, Josh, the cleaning people at the hotel are about to come, start cleaning the room around you, right?
They are actually in the hallway. I don't know if you can hear them.
The reason I'm thinking about this is I just got back from Scala by the Bay, and I was staying at a hotel in Oakland, and there was an earthquake that woke me up, and in my first moment of being shaken awake by this earthquake, what I thought was happening was that I had slept in, and that the cleaning people had come, and they didn't notice that I was in my bed, and they were cleaning the room anyway.
Yeah.
I thought for a second you were going to say they were shaking you awake, like, Mister, did you get up? No, but
what are you doing? Yeah.
Well, the earthquake was clearly Dotty finally being GA. I don't know.
So I wasn't there, but you did the Puzzlers live at Scala Days, I think, and managed to. Did you stump Martin?
Yeah, well, we stumped Martin because Martin actually wrote the foreword for the book. So he obviously kindly wanted to make sure that as he was flying back from whatever talk he was trying to write the foreword over the Atlantic, that he wasn't promising people that they were going to have a great time when they were reading a pile of garbage. So he tried a lot of the puzzlers, and he got about half of them right, I think is what he said. What was more impressive, I think, in the talk was that I think we had both, well, who was there? Adrian was there, Miles was there, and Daniel was there, which is, I guess, how this interview came about, because I know you discussed the puzzlers in the previous episode. And they were stumped by a few, which is always gratifying. And I think this goes back, actually, ironically enough, to the discussion we were having earlier about Puzzlers as a style guide to some extent. I think what Daniel said, if I remember in the last episode, is exactly what I have in mind as well. Like, puzzlers tend to touch parts of the language that he had kind of lasered out of his brain. And this is, I think, one of the key survival skills in Scala. It's to know which bits to touch and which bits to leave well alone. And I think one of the best things we can do for new people coming into the language is to make it easier, rather than to have to lobotomize yourself over years of programming Scala, which those bits are. And I mean, hopefully, Dotty, part of the development effort that's going into Scala right now is about doing that in a more effective way, whether that's through actually disabling parts of the language or whatever, is to make it safe for use unless you're an expert.
To be fair, the two things that you mentioned right now are unaffected by Dotty because they're actually library implementation details, which are always fun. Always fun. Yeah.
Yeah. And
anyway.
You mentioned near the beginning that you could kind of classify the puzzlers into ones that are inherent problems. That is just like that they come from what Scala's ambitions are, and that there are others that are more sort of accidental. I wonder if you could divide it even further into like puzzlers that a static code checker like Scala style or Abide could probably detect and say, you know, you're doing something there you probably didn't mean, or whether there are I guess the most pernicious category would be the ones where even a checker would just have to be like, hey, this looks good to me, you know.
Not Andrew. Do you have any thoughts on that?
Sure. Yeah, so we definitely had, I would say, a couple of puzzlers where in the book we explicitly mentioned that as of the latest version of Scala, you know, if you turn on certain compiler flags, you will get a warning. So at the time when those puzzlers were collected, that didn't exist, but later on that was kind of fixed. So I think Andrew, maybe or not Nerman, maybe you can correct me. I think there were only like a couple of those, and they, in my opinion, they represent a minority, but I'm not sure if you would agree.
So now
Did we lose Andrew?
no, we didn't. We were just waiting for some enormous street cleaning truck to pass. It's going to drown out everybody's sound. So I think, yeah, I think there are actually a few word remover rules that cover some of the puzzlers. I think some of the most pernicious ones. So one big category of puzzlers is around implicits, and there are certainly some parts of implicits that definitely could be called by a checker. And in fact, I know that if you look at the Scala roadmap, I think it's 16 or something like that. Some of these things are actually going to be at least deprecated, if not impossible, in the language. Like there's one. All right, Josh, just refer to you.
Yeah.
You need to go.
I gotta run, guys. I'm sorry, but it was really great to have this. I think Seth's going to continue the interview a little bit, and I agree that implicits are the thing that you should go to Scala Puzzlers right now, do every single thing that might even hint at implicits, and learn that crap if you want to be a master Scala developer. Like, knowing how not to use implicits is probably the most important skill you will ever learn. Yeah, when you go back to your code base from 5 years ago and look at how you used implicits, you will always cringe, no matter who you are. Yeah, anyway, so. But thanks, guys. Appreciate it.
That is
What?
the t-shirt right there.
I cringe at my own.
No, so
yeah. Sorry.
All right,
We're having
Josh.
network issues. All right, see you guys.
Yeah.
Thanks, Josh.
So we caught you.
So I mean, just to finish off that thought, go on. I'll just finish that off that thought quickly. So I think around implicits, yeah, there's a few things. Like one category that will hopefully be banned are implicits that end up being self-referential unintentionally because you don't declare the type. There are some other things about implicits that would require a change or a clarification in the language spec to fix. So things like the fact that implicit defs and vals that are functions. So if you have an implicit val that's a function type versus an implicit def, the priority of those is, well, it's a compiler choice, if you like. So those kind of things could clearly be done. I'm just not quite sure how a static checker would find that. It could say like, oh, you have a val that potentially has the same inferred type, or the compiler can get a function out of that. That could also be warned. But those are some of the areas that really wind up with some real weirdness.
Yeah, I think an interesting category of puzzlers around implicits is around the fact that implicit conversions and implicit values are actually not two different features. I don't know how widely known this is, but an implicit conversion is nothing more than a value that's in implicit scope that has function type. Is this in the book the one where, like, if you have a set in implicit scope, then because set is a function, then the set will also function as a conversion?
That's one. That's a specifically funny one that got Daniel that he really liked.
Yeah. Yeah, I like that class too. It's an example of where sometimes the fact that implicit conversions are not really a distinct category semantically it's like a thing that's simple from the point of view of we're getting all these behaviors that we want with a minimum of features. But it trips people up because, like in our heads, these are separate things. The language is more complex in our heads than the simpler spec.
Yeah, and I think that's actually an excellent point, because I think this goes back a little to what I was trying to say earlier, that part of the genesis of a puzzling feature in any language is a user's expectation. And this is an excellent example where, you know, the implementation has been done in a very efficient way by piggybacking on the back of, you know, things like overloading resolution, for instance. The normal part of the language, if you like. But there is a mismatch, at least for me, with implicits initially, because I've taught myself to think about implicits as something different. And you know, so one particular puzzler. So here I'm going to give one away for those of you who haven't done them all yet. One particular puzzler resolves around the fact that because implicits are indeed just regular values, just regular members, if you like, of a class, you get the same rules with shadowing. So if you have in a subclass, you have an implicit that has the same name as an implicit in the parent class, only one of them is visible to the code. But I never think of the names of implicits as being relevant, because implicits are all about the type. So you can set yourself up in a situation where you have, you know, what you think of as two, say, int to string conversions. And if you happen to use the same name, then only one will be visible and everything will compile just fine. And if you happen to use different names for them, you're going to get an ambiguous implicits error. And you know, that's been discussed on Scala Lang a few times, because again, you see, you know, it makes total sense if you understand that they're just quote unquote regular things, but it somehow violates the expectation that at least I had about what's important about implicits.
So yeah, once we start talking about implicits, my brain just starts chewing on it. I've got to make it stop if we're ever going to move on. So when you do these live presentations of the puzzlers, what's the format and how does that work?
Not Andrew. Over to you.
I'm sorry, I just didn't hear the question. The format of what?
The talk.
When you do the live presentation of the puzzlers.
Oh, right. Yeah, I guess we kind of you know, initially mimicked, you know, the Java puzzlers talk to some extent, but it's essentially showing the code snippet that forms the puzzler, going maybe here and there, giving some hints. Most of the time, I guess not, and then showing the four possible answers and giving the audience some time to think about it, and then kind of you know, seeing or checking, you know, who thinks what answer is the correct one, which is kind of always fun to see, you know, what percentage of people think the correct answer is, and after that, obviously, revealing and explaining. That's kind of the format.
Yeah, and obviously what we try to do, I mean, we try to make it fun, right? Typically, puzzlers, the talks are set up to be at the end of Scala days, for instance. And you've just spent 2 days trying to get your head around, you know, introductory category theory or whatever talks you've happened to be to, and that's great. But at some point, like, your brain hits overload level, and the last thing we want to do, after all, the goal is for this to be fun and educational at the same time. You know, it shouldn't be like an exam or something like that. So we try to bring in things like popcorn or whatever, which sometimes gets us into trouble with the event, you know, the venue. But it's, you know, you're supposed to have a good time, you know, and you'll get some of them right and you'll get some of them wrong, and clearly if you go to 2 puzzlers talks that are very close together in time, chances are you'll see a bunch of the same puzzlers. You know, by the time next year comes around, unfortunately, there's always new ones. And so yeah, it's the idea is, you know, you're supposed to come out of it having learned something about Scala that you didn't know before. If you got all of them right, then good for you, but then probably the talk didn't teach you quite as much as you might have hoped. One of the things that we don't typically have time for when we do them live, because we tend to do about 5 to 7, which is 5 minutes each, that kind of uses up all the time. One of the things that we spend a lot of time doing in the book is discussing how you can actually avoid these problems. So not just explain what's going on, but also, you know, what can I take away from this to make sure, like, stuff doesn't happen. One classic example that I actually only discovered about writing the book is that you can unimport specific predefs. So one of the famous puzzlers is around, well, in fact, you could say it's a whole class of puzzlers, any to string add. So, you know, this is one that arguably is related to the attempt to be JVM compatible or Java compatible, so maybe it's necessary. But in Java, you can add anything to a string because you can convert anything to a string. And in Scala, that's implemented through an implicit in predef called any to string add, which I think is an implicit object, actually, or an implicit def, I can't remember. The point is that that can cause some really weird behavior. And it's actually possible in Scala, which I learned, to unimport not the entirety of predef, which of course will break 95% of your code, but only that one specific element. And you have to follow some rules, like you have to do it right at the beginning and that kind of stuff. But that's, for example, a really good takeaway from, you know, if you want to avoid that and you want to like stop having these weird things in production, here's something you can take away from this to learn.
Yeah, I've heard there are some folks who actually turn off all of predef in their production code.
And then they have predef 2, which does half of this stuff that they've written themselves or something. I don't know. Well, good for them.
Yeah, the particular, I remember seeing that Rob Norris, aka T Polecat, had done that to his code. So if we ever have him on, that's something we have to ask him about, like how that works out.
Yeah, I could imagine that you would have to add some stuff which is already defined anyways, right? So I guess the question is, what is easier to do at the end?
Blacklist or whitelist?
Right.
Classic security problem.
So was Java Puzzlers the first the first book in the first book like this, and are there similar books for other languages as well?
It's a good question. I'm pretty sure somebody did punch card puzzlers at some point. Right? Like what happens when you do a, like, I don't know, a butterfly in a punch card. But
right.
as far as I'm aware, Java Puzzlers was the first, well, at least was the inspiration from my perspective. I'm not aware of this kind of thing in other books. But there are plenty of, I mean, there are plenty of programming books that fall somewhere in the space between like challenging you to solve small problems. Some of them are more like programming like exercises than they are necessarily puzzles. But I'm pretty sure that we weren't, neither Java nor Scala were the first ones to invent this notion that something is non-intuitive in a computer. But it is the first book that I'm aware of.
I think I heard, but I'm not entirely sure. Maybe I came across that there's a like puzzlers in C#, but again, I might be just dreaming.
Is it called like sharp edges? No.
Yeah, I would have to Google it.
Ooh.
Gruesome, yeah. So maybe a question for me, for you, Seth, given turning this around, given that you have all this inside information that I am not privy to. I have heard, and I would be very glad if we could get rid of like 95% of these puzzling cases with Dotty. I'm not sure how that would work in terms of the stated goal of like not breaking a lot of code, but definitely if we can cut this in half and make puzzlers an endangered species, I'd be all for it, especially since I've already bought dottypuzzlers.com, so we're safe, right?
Right.
But maybe you can give us some insight there.
So I'm not really that actively following what's going on in Dotty. We have our hands full with regular Scala. We are sort of spectating. I don't think that Dotty will solve that many of the puzzlers in your book. I would like to be wrong about that. Well, so I don't think it will solve them right away. Let me answer this in two parts. So the focus in Dotty is not on some sort of general cleanup of the whole language, but it's specifically about the type system and about trying to achieve this simplification and unification in the type system where type parameters are turned into just being sugar for type members. So any puzzler that isn't anywhere in that in the vicinity of those issues, I think is unlikely to get fixed. So that's that's the short-term answer, but there is maybe some longer-term hope where, in addition to getting the simplified type system out of Dotty, we're also getting not an entirely freshly written compiler, right? Because Dotty is going to still use the it's still going to use the backend from regular Scala C. We are getting a fresh code base in which it will be easier to make simplifications for. I mean, there may be some puzzlers that are basically ought to be fixable in the current Scala, but just aren't getting fixed because the compiler is a difficult code base. But that any hope there is still quite a ways off. For the most part, the goal with Dotty is to compile the same language. I mean, certainly there are some exceptions. So. Yes, hope, but not too much and not too soon.
Well, and maybe to follow up on that, because I mean, yesterday, this is a bit of a serious question, and I know hopefully that we're not going to dive too deep into the seriousness here, but it made a big impact on me going to this Scala meetup. It was a scolding meetup, actually. They were talking about using scolding at Etsy or whatever, and I was really surprised by the amount of questions at the end that were all related to, so, what's the complexity of introducing Scala, how do you handle that, and so on and so forth, and that's how Puzzlers was mentioned. But I would be grateful to hear what, if any, advice you have for people for how to make, and I know, Norman, you're doing some stuff in the real world day job type stuff right now. I think the audience, it would be interesting to discuss for a few minutes how you would recommend going about making Scala sane and safe for use, not just when you've written the code 5 minutes later, but as Josh was saying, when you try to look at that code 6 months down the line.
I guess so that's a really big question. I think that there's a lot of possible answers and angles from discussing that. I'll just give one answer and say that I see a lot of hope in doing automated checking. When earlier I asked which of these puzzlers could a checker catch, I suspect that the answer is actually most, but we don't necessarily have these checkers yet. So I'll plug this new project that's started by a student at EPFL and that Adrian on the Scala team is now working on, called Abide. That, unlike some of the other checkers, is based on the real compiler code base. So there's a possibility of writing rules that do some pretty sophisticated semantic checking and not just surface level. So I hope that people will not only consider using the tools like that and warp remover and so forth, but also on basically helping us build them. Abide is more of a platform for writing rules. It probably won't ever have a big database of rules unless people contribute them.
No, Andrew, you have any thoughts?
Sure, yeah. So I think, as Seth mentioned, I mean, the obvious one is there's a set of flags, compiler flags, that you basically want to have turned on. No question about that. And I think that's a good start. I also think, I mean, obviously that problem can be solved on many, or attempted to be solved on a couple of levels. But the two that come to my mind is some kind of a style guide, which would be enforced, and then the code reviews, which can reveal a lot. And something that I actually just came across very recently is the Spark Scala style guide, which kind of makes sense because the Spark project has a lot of contributors, and it might be at this moment the biggest kind of Scala open source code base. I'm not sure about that, so I'm saying it might be. But when I read their style guide, I was at the end, I was kind of astonished. And the reason is that, a lot of Scala features basically are recommended not to be used in that style guide. And Andrew, it seems like you're trying to bring that up. So there are possibly areas where you would say, well, this might be ambiguous and you don't want to use, but then also code reviews. So this is something, in the beginning when you start writing Scala, and I went through this phase as well, where you're really proud of those like one-liners. Like you wrote a whole lot of functionality, and you were basically chaining stuff together and kind of all fitted on one line. And then when you look at that code 3 days later, you just have trouble understanding, what is it actually doing. Those kind of things, they actually mentioned that in the style guide. I think it's called like a 5-second rule. Like if you can't figure out in 5 seconds what the code does, you shouldn't try to use it. So I think the same kind of reasoning should be applied, even towards puzzlers. If you're reviewing someone's code and you cannot immediately, or it's not obvious, what it's doing, that is kind of a red flag. It should be simplified, or broken up or something. So I don't think, maybe to fully answer the question, I don't think there's a silver bullet. I think it's something that needs to be addressed on from several sides, but it can certainly be kind of improved or the chance lessened for those to creep up.
And I think actually it's good that you mentioned that. Let me throw another one into the mix here. There's also something called SuperSafe, which is a compiler plugin, which Bill Benners, which is coming out of a little bit of Scala tests. So there was an interesting presentation at Scala Days where he was talking about using not just tests but then also types and then compile time checks for basic things that you want to avoid. But let me just throw that in there. I think obviously it's great to see that these things are all happening right now, and hopefully, as you were saying, Seth, they're not finished yet, but it would be great if there was some kind of convergence of these three. So that what you're saying, Norman, for instance, yes, you have a code style guide, but you want that code style guide to be enforced, and obviously that'll be a lot easier if, for instance, say the Spark code style guide has a corresponding set of abide checks or SuperSafe checks or whatever it happens to be, so that you can actually try to match up what your expectation is with what your code is being checked for.
Right, and some of them I think it would be fairly easy to enforce. For example, in the Spark style guide, I think they recommend against using implicits entirely, and I think that's would be fairly easy to enforce.
You can do that with grep, right?
Yeah, I mean at the end of the day, some are not, but basically, if you enforce that, no use of implicits, you kind of eliminate, I think, a big chunk or some amount of puzzlers.
Yeah. Andrew, if you're done, you should turn off your screen sharing.
Thank you very much. Yeah. Good hint.
I'm glad that somebody brought up Spark, because when we're thinking about recommended style and about making the language safe, the fact that we have so many people coming in a Spark context is it's an opportunity, and who are using Spark are not like full-time code all day, every day types. If they're data scientists, then code and code quality is not what they want to be thinking about all the time. It's just like a different audience than a typical Scala user that we have now, who's like hardcore back-end developer. And so I think a lot of these people have more need for something that helps them do Scala well and do it right.
And I think that's actually, I mean, to me, that's been one of the most interesting recent things about watching the Scala community. I mean, as you say, I think I'm very glad that Spark exists, mainly because, well, for the first time, there is a natural stream into using Scala as a language without necessarily coming from the Java background, which was, I think, probably the biggest, if you like, nurture pool up until that point. And indeed, a lot of those people, a lot of them, I know for myself, a lot of, coming from a Java background immediately brings with it a lot of baggage, like mental baggage about how you think about the language. And of course, going back to some of the intrinsic versus accidental complexity in Scala, a lot of the things that go on in Scala, or at least a substantial class of puzzlers, come from interaction compatibility with Java and the JVM. And I think the Spark community, to me, has thrown up a fascinating question. If we find that a significant proportion of the Scala user base starts to become a group of people that have no Java background, to what extent is that high level of Java interoperability still interesting or necessary? I mean, that doesn't mean we're going to get rid of it because of backwards compatibility reasons, but I think it certainly changes the value that we would potentially place on it. And I think mobile is another such area where there is a huge potential, but of course there's much less movement in that area right now from Scala's perspective.
Yeah, I would, if you're asking about fixing puzzlers either in Scala 2 or in Dotty, like to have the freedom to break with Java in more respects would be awesome. I mean, it doesn't necessarily mean it's advisable, right? That there are real reasons to overlap with Java, but there's a lot of areas I'm just like, oh man, do we have to?
I guess
so
we all agree.
There's someone in the audience who you obviously planted, a stooge, who is asking, is there a coupon code for the Scala Puzzlers book?
That is an excellent question. Obviously, we haven't planted the stooge because we don't have a ready answer. But what we can do is, by the time the transcript of this goes up, we will make sure that such a coupon code does exist. And for the kind stooge who did ask the question, please go check the transcript when that's ready, and we will make sure there is a coupon code in there.
All right. Okay, I will do that in the notes. Thank you, Patrick, who is not a member of either Andrew or Nerman's family. I'm sure. There's a little photo and everything.
All right, Patrick, you can come out now.
All right, I think we're done. I'd like to thank you so much for coming on the show. It was awesome. I'm the last host standing. Like you scared Dick off before the show even started. Josh should only take it halfway, but we're here to the end.
Yeah. I think the technical dropouts got him. So thanks to everyone who lived through those, and yeah, thanks for having us on the show. It was a lot of fun to be here. I'm looking forward to the next one as well.
Thank you from my side, yeah, and thank you, Seth, for sticking so long, and until later.